get a little bit worse very soon, because the browsers have agreed to limit the maximum lifetime they allow for TLS certificates. So in a few days, the maximum lifetime will be 200 days for a certificate. In 1 year, it will be cut to 100 days, and in 2 years, it will be cut to 47 days. So a lot more rotations are going to be coming very soon. And sometimes these rotations, it can disrupt some applications. And once we do it with shorter TLS certificate lifetime, then we'll have much more frequently these opportunities to have incidents because of TLS. So can we do better than restart? Or of course, it's already a good solution if you restart your application if the TLS certificate has changed. But can we do even better than that? So cert-manager is maybe the de facto way how to handle certificates in a Kubernetes cluster. So typically you have a user who requests it either directly or they add an annotation to gateway or an ingress. Then we specify the name, subject, etc. Then the cert-manager operator will create the certificate request, and with the cluster issuer or issuer that we have configured, it will go to a certificate authority to issue the certificate, and then creates a secret where we have the TLS certificate and key. And typically you mount it in a pod with a volume pointing to the secret. So this talk is mostly focused on this part. So how do we use the certificate values from a pod and are able to refresh it without having downtime in the pod. So the basic solution, which is as popular as hamburgers because it has over 1 billion downloads on the Docker Hub, is the Stackhatter Reloader, which will look at the annotations on your pod, and then determining those, it will trigger restart when a watched secret changes. So with this approach, we are able to trigger a restart when the certificate is updated. But some applications don't like this too much, so they lose their internal state and they lose their connections. Maybe if you have a lot of replicas running and you don't have a stateful application, then this isn't such a problem. But if you have larger stateful application, maybe it's a Java monolith, or even worse, it's a clustered application that each member in the cluster have some state that they are processing, and clients depend on that node to be available. And for instance, Elastic or OpenSearch, they very much match all of these definitions, that it's a stateful clustered application that's a old faithful Java monolith. So how could we avoid the restarts? Let's first look at the secret updates. So on Kubernetes, we can define a volume in a pod spec that references a secret that contains the certificate data. Then we define a volume mount in the container. But if we want the secret updates to be reflected on the pod, we shouldn't use the subpath, which mounts individual files, but we should take all the volume contents. So then they get mounted on a temporary file system, which is on memory of the machine, on the underlying machine. And over time, the changes in the secret are reflected on the mounted volume. But it may take over a minute to get updated. So there is a delay determined by the kubelet sync frequency and a cache TTL. So it may take over a minute to be reflected on the pod. And this is described on the Kubernetes documentation pretty well. So a better solution, we could try hot reload by polling. So we have some kind of trigger in the application that every minute, every 5 minutes, we go look and see if the files have changed. And if they have, then we will reload the certificate file and refresh the listener so that we have an updated TLS context. And luckily, this is already supported in many frameworks and applications. So most importantly, maybe in the Java world, the Spring framework, where in the SSL bundle, you can specify the reload on update flag, set it to true, and it will get automatically updated. On Quarkus, reload period, for example, setting it to 60 to probe it every minute. And of course, in applications that use Quarkus in the background, like for instance, Keycloak is now built on Quarkus. And other applications built on these frameworks. Then on OpenSearch, there is a flag, hot reload enabled, which will also accomplish this without restarting the OpenSearch cluster and causing a big mess. And then there's also really nifty library for adding support for Java, Kotlin, and Scala. So this will create the SSL context object, and you can give it to the framework when you start to listen for incoming connections, which will restart, reload the certificate material once it's been updated. Or we could monitor the files as they are stored on the secret volume. And in the Linux kernel, there is a mechanism called iNotify. And it's a lightweight way to get an event when a file has changed on the disk. And if you would like to test this first, there is a package, iNotify tools, that will show what kind of information this interface will show you. In the case of Kubernetes secrets that are mounted in a pod, there is a slight caveat to this, because the kubelet first project, so this kubelet projects an updated secret first to a timestamped path. Then it updates a symlink that points to the updated path. And this makes it atomic, so that, for instance, we are never caught in a situation that the TLS key has been updated, but the certificate has not been updated. So from the point of consumer, it will look like it's an atomic operation. But however, if we just watch the TLS certificate file, we won't see that it has been updated because it's still there maybe somewhere and not being deleted. So we need to follow the .data symlink and see when that has been updated, then we know that the secret has been updated and it's been projected to the pod. And I wrote a proof of concept with some help from Claude based on Connect RPC. So that is a gRPC and REST framework in Go And basing it on the tutorial, see, it's on GitHub. Project name Kataja/hot reload connect RPC. So we have a client and a server here. And the really interesting thing is on the server. So this was essentially taking the connect RPC tutorial, or like hello world, and adding the cert loader. So this uses the fsnotify library for Go, that on Linux it will use the inotify on the background. So here we specify the watcher and add the library, the certificate path there. And depending on if we have the symlink, so then we know we are running on a Kubernetes and the certificates are mounted from a secret. Then we have the .data, and we need to follow that instead of the file directly. Then we have, it'll fire some events, and then we know to reload the certificates.
Can you make it bigger?
Sure. Let's see.
Thank you.
More. So we have the TLS config. And now the get certificate function will call it from the reloader, which will return the most recently updated certificate and the key. And otherwise it's just the hello world business. Right, so let's run the server. Let's try that again. So now it's listening to connections. And let's probe the API. And the client will now output also the certificate validity period. And every 2 seconds it will poll the API. Now let's rotate the certificate. You see the validity was updated. No, doesn't zoom very well, sorry. And then have it running here on a EKS cluster. I'll forward the port here. And start running the client. And call cmctl renew. So this is cert-manager renew. And specify the namespace where the application is running. Now it might take a moment, but meanwhile, BusyBox contains the inotify-d tool. So it will essentially also print out the information we can get, or the events we can get from the inotify mechanism. Any moment now. this is starting to look like a real demo. Now we get some more data. So here we see these are the events that were fired from the iNotify. And now the certificate validity has been also updated. So the client received an updated certificate without us needing to restart the application. Then on the logs, we saw TLS certificate reloaded. Now, where's my presentation? So, summary, this hot reload will avoid restarting stateful, long-lived services that might not handle it so well. These certificate rotations are becoming more frequent, and if everything goes smoothly, it will be also easier to reduce the TLS certificate lifetime in your private CA, for example, to be rotated every week. If it's less painful and causes fewer incidents than just restarting everything every time there is a rotation. And I think now is a good time to adopt hot reloading, especially since it's, with many frameworks, it's a low-hanging fruit. If we can flip a configuration to update the TLS, then it's an easy win. And contribute it to your projects that you use. And then it should be causing fewer incidents over time, especially since this rotation is going to be much more frequent. Any questions?
Very much.
Welcome.